Bismillahirrahmanirrahim. So let us consider the outcomes and sample space of a probability experiment. So the outcome of a probability experiment is any possible observation of that experiment. So this is also called, the outcome is also called a sample point of that experiment. And the sample space of a probability experiment is the distinguishable, mutually exclusive, and collectively exhaustive set of all possible outcomes, right? So the outcome let me draw a line here. So an outcome if of an experiment is any possible observation of that experiment, right? And this is also called a sample point. And outcome is also called a sample point of that experiment, right? Sample point. And what is the sample space? The sample space of a probability experiment is the set of all possible distinguishable, mutually exclusive, and collectively exhaustive uh, outcomes, right? Set of all possible outcomes. The sample space of an experiment is the distinguishable, right? These properties are important. The outcomes can be distinguished from each other, right? Distinguishable, DIS, distinguishable, mutually exclusive, collectively exhaustive, set of all possible outcomes. So you note it is set of all possible outcomes, and these outcomes are distinguishable, mutually exclusive, and collectively exhaustive. So an outcome is a sample point, right? This is a sample space, and each element is an outcome of that experiment, and that outcome is also called a sample point of that experiment. So let us do some examples. For example, let's consider an experiment. Toss a coin 2 times. So different kinds of observations can be made. Either we can be interested in the sequence of heads, or we can be interested in the total number of heads, right? So let's in this experiment observe the sequence of heads and tails, right? So for example, one possible outcome, if we tossing a coin 2 times, that first in first toss we get a head, and the second toss we get a tail, or we get both the tails. These are two possible outcomes of the experiment. So all the possible outcomes will be, for example, we get all tails, or we get a tail and a head, or we get a head and a tail, or we get all heads. So these are the four possible outcomes of this experiment, and these are the all possible outcomes that there can be. So that this is why this is the sample space of this experiment. And similarly, let's consider another example. Let's consider the same experiment with a different observation. For example, toss a coin 2 times. And now let's observe the number of heads. Observe the number of heads. So there can be no head, there can be one head, or there can be 2 heads. So the sample space of this experiment will be either 0 or 1 or 2, right? So see, the procedure in both the experiments is the same, but we have a different sample space for each case. In this case, the sample space is the sequence of heads and tails. In this case, the sample space is the number of heads, which is either 0, 1 or 2, right? So let's further elaborate this with another example. For example, toss a coin only once, right? So observe head or tail. There are not many observations that we can make from this experiment. So observe head or tail, right? So the sample space is head or tail, right? So this is a particular type of experiment in which only 2 outcomes are possible. So such experiments are given a specific name, which is called Bernoulli trials. So the experiments in which the number of possible outcomes is only 2 are also called Bernoulli trials, right? So let's consider another example, which is again a Bernoulli trial, for example. So test an integrated circuit. Test an integrated circuit. Observe it is functioning or not, and based upon this, accept or reject. Accept A or reject, denoted by R. So the sample space is A, accept, and R, reject, right? So similarly, example from engineering, for example, read a binary bit. Read a binary bit. Observe 0 or 1. So the sample space is 0 or 1, right? So this example 3, 4, 5, all these are examples of Bernoulli trials, because the only possible outcome, there are only 2 possible outcomes, right? So let's consider an example. Transmit a signal and observe whether the received signal whether the signal is received or not. Observe if signal is received, right? So received denoted by R, or not received by N. So the sample space in this case is R and N. This is a Bernoulli trial again. So for example, another example, weight of men recruited in army between 60 and 70 kg, right? uh, Weight of men, Meyer, or the weight of men um, between 60 70 kg, right? So this could be now 60, and between 60 and 70 kg it can be 60.1, it can be 66.7, or any continuous number between 60 and 70 kg. So we can express this kind of samples with this notation. This is equal to W, the weight, while W is greater than or equal to 60, less than or equal to 70, and W is element of set of real numbers, right? So there can be another example, a similar example. Temperature recording. In summer of a city, right? City of Lahore, for example. So this could be, this is also a continuous sample space. So this is temperature, while the temperature is for example greater than or equal to 25 and less than or equal to 50, while temperature is element of set of real numbers. So this is another example of a sample space, right? The outcome could be, for example, on a hot day it could be 42 degrees Celsius, 43 degrees Celsius, right? The temperature recording in degrees Celsius, right? Let me specify in degrees Celsius. So so the outcome and the sample space we have seen in these examples. The sample space can be a discrete sample space, like in this example here, in example 2, 3, 4, 5, and also 6. These are examples where the sample space are discrete, and we choose an outcome from these sample spaces, right? And in this example and in this example, the sample space is a continuous, right, over some interval. So this is a number, any number, real number between 60 and 70 kg in this case, and in this example, the outcome, any possible outcome, is a real number between 25 degrees Celsius and 50 degrees Celsius. So the sample space can be discrete or continuous, and an outcome is a sample point of the sample space, is an element of the sample space.